So this is not a pangolin, before anybody thinks that I forgot what a pangolin looks like. This is an aardvark, but it is another animal that occurs in the Kalahari. Our research group did some work on aardvark before, and I showed that this particular animal is very specialized in terms of their diet. They're very specialized on one species of termite. And what happens is, with climate and with drought situations, if that species of termite declines in abundance, this animal becomes in trouble. And you can see this bad body condition of this poor animal. You can see the hip bones, the spine. So for something like an aardvark, you can see that. But for something like a pangolin, you can't see that. So we had to do some different research, not too different, but we had to try and look into it from a different angle to try and find out whether they are struggling or not in the winter time. So the question really after this aardvark work was, what about the other insect-eating animals? Do they respond the same way to environmental change, or what is the situation? Which is then when, excuse me, my work came in on Temminck's pangolin, which is a pangolin that occurs in southern and eastern Africa. So we have 4 species in Africa and 4 in Asia. This is just one species in Africa. It's ecologically similar to an aardvark. So it lives in burrows. It comes out at night predominantly. It eats ants and termites. The difference is that it has scales instead of fur like an aardvark. And it's currently the most traded mammal on the planet, illegally traded mammal on the planet. But it faces a number of other threats. There's road mortalities, there's electrocution on electric fences in southern Africa, habitat loss. But one thing that's not ever really mentioned is the potential impact of climate change, which is where we came in with our work. So these are some of the latest climate projections in Africa. On the left, you've got the temperature changes, and on the right, the blue ones, you've got the rainfall changes. So even just in a 1.5 degree scenario, if global temperatures increase by 1.5 degree, you can see parts of Africa are going to get hotter, equally hot and drier. Not all of Africa is going to get drier, but certainly most of Africa is going to get hotter. And this is quite concerning. There is quite a bit of debate about what happens with the rainfall, whether it decreases in certain areas, increases, or stays the same. But we need to think about it. If it did stay the same, let's just hypothetically say the rainfall never changed. Even with these increases in temperature, you've got increased evaporation. That means you've got less groundwater, and that means a lot of things in your ecosystem suffer. And then there's going to be massive cascading effects through that. So even if we exclude the rainfall debate, the increasing temperatures will be a problem for animals, both directly and indirectly. Directly, it can impact an animal just by physical heat on its body and having to regulate its body. So you have to work harder to regulate your body. And then indirectly through its food resources. So something like an insect eater will be impacted by the indirect effects of climate change, because increased heat and aridity will impact the insect populations. And so through that, there will be impacts on our anteaters. This is some of the older models, but I'm using it now because I've just outlined the pangolin distribution within Africa and to show you where my study site is. So that black bordered outline is the pangolin distribution in Africa, not just the Temminck's pangolin, it's all the species. And the very bottom left of that is the southwestern distribution edge for the Temminck's pangolin. And that's where I'm working now at Swalu Kalahari Reserve, which is in the Northern Cape province of South Africa. It's fairly hot and dry. I can vouch for that. But it makes for a nice study site because it gives us a sneak peek into the future where similar conditions might become prevalent elsewhere across Africa. But that southwestern region is really predicted to get hotter and drier. And so if pangolins can't deal with these hotter and dry conditions, we might see range contractions. So that black bordered outline won't be quite as big as it is now, sadly. So my work at Swalu, I did my PhD for a couple of years here. And we had tagged 6 different pangolins, well, actually 7, but I'll get to that later. So we tagged them with VHF tracking transmitters, and that really just allows me to track them live. Being able to track individual animals is very important and really gives us a nice look into their little secretive lives, because they really are super shy, super secretive. If they hear you coming, they hide in a bush. You won't even know they're there. mostly nocturnal when most people are asleep, and so finding them is quite tricky in the first place. Thankfully, in the Kalahari, we've got a nice substrate. We've got nice open roads where we can see tracks going across the road. So pangolin tracks are quite distinctive. You can see in this picture. This was actually a picture taken the day that we got back from very strict lockdown. We finally managed to get back into the field, and our first drive out, and we found pangolin tracks going across the road. So we're very, very excited to see that. That's Valerie. She was another PhD student doing work on pangolin and aardvark. And usually you can see the tracks go across the road and then into the veld behind us. You can see it's fairly nice and open. So usually one would be able to track a pangolin to its burrow, and then we would sit there and wait for it and then tag it with one of those tracking transmitters. Sometimes, however, when we get some rainfall, the veld looks like this, which is then not so easy to track pangolins. And I always make a joke with my colleagues from the eastern side of the country where this is their habitat. It's just ground cover for days. It's really hard to track a pangolin. So for the first time after our crazy rainfall this summer, I experienced what they experienced. It was super tough tracking a pangolin. In fact, I didn't even bother. If I saw tracks going across the road into this thick vegetation, I just curled into the fetal position and cried a little and then carried on driving, because there was just no way I was going to track that animal there. But it's all fun. So with the pangolins that we tagged, we wanted to get an idea of what their body temperatures were. And so that meant having to do field surgery just to minimize the impact on the pangolin. So we would go into the field, find a pangolin that we had already tagged, bring it to a mobile surgery site, which looks like this. It's really just a bucky with a mosquito net behind it, just because at night lights attract millions of insects, and we don't want that around an animal that we're cutting open. Of course, some people just stand around and stargaze while the rest of us are patiently waiting for a pangolin to come out of its burrow. But it's all part of the fun. It's a very exciting procedure. And then we anesthetize the pangolin. We just pop it into a box. We don't have to dart it. Put it into a little Perspex box and then pump some anesthetic gas into the box, and it falls asleep, uncurls, super easy. Our procedure is maybe half an hour max. Pop a logger into it, let it wake up, and it goes off totally normally. It goes back to feeding very, very quickly. So it's a very nice, refined technique that we've got going there. So in total, I had 7 pangolins, 4 males and 3 females. If anybody in the room does know their pangolins, you might think 6.5 to 9.5 kilograms is quite small. Our pangolins are generally smaller than those on the eastern side of the country. Again, this is just Temminck's pangolin. Rod's probably thinking, but my pangolins are much, much tinier than that. Yes, they are. This is just a Temminck's pangolin. And we managed to get a lot of body temperature records for these animals. They were logging at 5-minute intervals, and so we got close to 1 million records, which I think is really amazing. I think that's a really, really special data set to be able to get from a wild animal. So we're very excited about that. Then I also had to collect Pangolin Scat, which was a very exciting part of the job. Not everybody gets to see a pangolin poo in the wild. And so when I did find one, I will admit that there was a little dancing and singing going along with that, because it is a very, very exciting thing. I managed to get 98 scats from 9 different pangolins. They weren't all tagged pangolins. So if I found a scat opportunistically, I grabbed that as well, because can't miss that opportunity. I also placed camera traps outside their burrows, so I would track them in the morning and then go and place a camera trap to get an idea of what time they were coming out, becoming active, and what time they were going back to sleep. Unfortunately, they didn't always return to the same burrows, and so we had to find a different way to get some records, and the camera traps also just didn't always trigger. So from the camera traps, over 2 years, we only got 270 captures, which is not great, but through those body temperature records, we managed to get 4,000 body activity records, and I'll show you later how. We just used body temperature throughout the day to estimate the activity time. So they were doing some reptilian things more than mammal things at some stages. And then to look at some of the data. So with the pitfall traps, I placed pitfall traps every month to get an idea of food availability for a pangolin. So it's a tiny tube that you place into the ground, and ants and termites just freely fall in there. And then I get to sit and count everything that fell in there and ID everything that fell in there. And so overall, we've got about 17 ant genera and 6 termite genera, which is quite a lot for this area. I think it calculates to about 50 species that's available to pangolins. The most abundant, if you do know your ants, if you are an entomologist, was Monomorium and Phaidole, which was not unexpected. But if we look at this graph, you've got ant abundance on the y-axis and then the months of the year on the x-axis. Now, our winter period is June, July, August. So that was the period that we were particularly interested in. June, July, August. And you'll see that prey abundance decreased during this time. So food was scarce during the winter period. But we had 2 different years that we measured this across. And the first year was particularly hot and dry. The second year, we had some decent rainfall that actually fell on time. The first year, the rainfall even came a little bit late. So the second year, we had some nice rain. And you can see during that winter, food seemed to pick up, which is good. So we were really interested in these winter periods. We wanted to see how did pangolins respond to these food deficits during this time, whether it was behavior-wise or body temperature-wise. And so I used very sophisticated technology, of course, to first of all look at the diet in comparison to what was available, a bucket and a tea strainer. So that's just, you put the pangolin scat in the bucket with some water, and it separates the organic from the inorganic. In other words, it separates the little ant heads and legs that come out through the scat and the sand that falls to the bottom. And then you just sift it up with a tea strainer. Very, very sophisticated stuff. And then I spent hours and hours and hours and hours and hours and hours staring down a microscope, trying to identify exactly what was in that scat. So because the ant heads and termite heads come out perfectly preserved, it's actually super easy to tell what it is under a microscope. It's not ground up and scratched and banged up that you can't see what it is. So that's pretty unique. I never counted everything in each and every scat. We took a subsample, so just a small portion of it. Otherwise, to this day, I would probably still be busy counting scat content. So we just took this little subsample from that to try and see what they were eating. I used this brilliant book. If there are any budding entomologists out there or someone just with a general interest in insects, this book I would highly recommend, by Peter Slingsby. It's a guide really to the ants of Southern Africa, and it was super, super useful when I was trying to ID these ants. So highly recommend that if anybody is interested. Then when I was analyzing these scats, I realized that only 30% of every single scat is organic material. That means the other 70% is inorganic. And when I say inorganic, I mean sand. So anything that's not worth anything energetic wise. So it's not worth, it's not going to give the animal any energy. So 70% is just soil, which is really important for the pangolin for their digestion. So they're not wasting their time by ingesting so much sand. But we also noticed that depending on which prey they were feeding on, determined how much organic or inorganic content there was in the scat. So for example, if they were eating arboreal prey or prey that was hanging out in the trees, which is actually their favorite prey, they weren't taking in as much sand. But that means they could probably take in more food before they felt happy and not so hungry anymore. And then if they were eating subterranean prey or food that occurs under the surface, they were getting a lot of sand content, which again is a good thing for them. They need it for their digestion. So then some of the results from the scats, and I'm very happy and proud that this has been published as of this week, this diet work. So on average, a pangolin was eating about 15,000 ants and termites a night, which is a lot if you think about it. That requires a lot of energy for a tiny little pangolin that walks on 2 legs and has a very long, thin tongue. It's very sticky, so it's probably not that difficult for a pangolin, but it's a lot of work still. The range was between 1,000 and 60,000 ants and termites per night. So it is quite a big range. But if you calculate it to how much that is per year, that's 5.5 insects per year per pangolin. Think about that for a second. 5.5 million insects per year per pangolin. We don't just have one pangolin cruising around in ecosystems. We have a good number of pangolins running around. So that's a significant amount of insects being taken out of the ecosystem every year. But it can be up to 22 million if we look at the upper range, if they were eating 60,000 insects per night. 22 million insects per pangolin per year, per year. That's crazy. And we don't just have pangolins in these ecosystems. We have things like aardvarks and bat-eared foxes and jackals, whatever else that also contribute to eating insects. So if someone ever asks me what's the impact or the role of pangolins in an ecosystem, I don't have to go much further than to say this. I mean, they are clearly playing a role in insect populations in our ecosystems. I'm not saying that they keep populations in not in check. They're not going to prevent insects from taking over the world, but they certainly play a role in population dynamics and all kinds of insect-related things, because insects will respond to predation. So they play a huge role in the insect world. So I did a little comparison just by watching what a pangolin eats versus what it actually was eating through the scat analyses. And just by watching it, I only realized that they were eating 3 ant and 1 termite species, which is not very much if we compare to the scat, which I was getting 10 ant and 3 termite species. So it's very, very important to use the scats for analyzing pangolin diet. It's not good enough to just watch what they eat. It's very difficult to see what they eat. Having said that, a lot of the extra things that they were eating that I didn't detect from watching them probably were taken in accidentally. So I don't think they were intentionally targeting those species. I think it was just bycatch as a result of what was in the environment and what was around as they were feeding on the preferred prey. But it's very important to use scats when analyzing the diet. Of that diet, 86% were ants and only 14% was termites. I think a lot of people think pangolins are predominantly termite eaters. This species certainly is not. They love their ants, and yeah, only 14% is termites. And again, for the budding entomologists out there, if you are interested, overall the ratio was 50% chromatogaster, which is the cocktail ant. Yes, it's called a cocktail ant, it's pretty cool. And they hang around the bases of trees. And then Anapolepus, which is a pugnacious ant, quite an aggressive ant, but jam-packed with energy. That's a very, very good ant for them. Only 32%, and then Trinobotermes, which is the termite, that's 12%. And other ants only made up 6%, which is why I said that out of those 10 ants and 3 termites, they probably were taking that other stuff up just accidentally as they were moving around. And then I've looked at, between the 2 years, I wanted to look if there were seasonal changes in their diet. So I've only used summer and winter here just to avoid some confusion, and don't worry again about the scientific names, but overall we see that they preferred the green ant, which is the cocktail ant. But we were again interested in that winter period. What is happening in that winter period? Do they adjust the diet in winter when food resources decline, when food becomes scarce, when they are energy stressed? And we saw that they did, but the only real change that they made was that they increased their termite intake, which is the yellow part of the chart in the winter. So they took in more termites. We don't know why they did that. We couldn't really tell if it was because their preferred prey, the green one, declined in abundance. We couldn't measure that because they didn't fall into the pitfall traps. So we're not sure why they do that. There's a number of possible reasons, but I won't really go into that now. And then if you look at the second year during summer, there was a massive increase in the blue ant, the Anapolepus. And it seems to be that those ants really respond to rainfall. So when it rains, which it rained on time during that second year, these ants were massively in abundance and pangolins chowed them. They loved them. And again, they are jam-packed with energy. I then measured the energy content of the insects they were eating. So all you do is you collect live specimens, you dry them out, you grind them up, and you put them into a bomb calorimeter, which measures the energy content of a sample. And then you extrapolate that to the energy content per individual ant. And then you can say, okay, a pangolin ate 10 ants. What does that translate to in terms of energy? So the graph on the bottom right shows your energy intake across, again, just the summer and winter seasons. And in general, energy intake was low during winter. So despite increasing their termite intake during this time, energy intake was still low. You'll see that the first summer energy intake was also low. And that's probably because they ate a lot of those cocktail ants and less of everything else. And those cocktail ants are not very good in terms of energy. So as much as they love them, they're not really good to get your energy up. But those blue ants, the pugnacious ants, you can see in the second summer, when they ate a lot of those, energy intake was just skyrocketing. So that dry first year really impacted that super energy rich insect availability. And then the real gold of the research is this body temperature stuff that we got. So if you look at this, we've got body temperature records for, I think it was a year, maybe just less than a year for one pangolin. And this is the raw data, but it's also plotted with the mean. So we've got body temperature on the y-axis and then the months of the year on the x-axis. And you'll see body temperature is quite low relative to normal mammals. So it was sitting between 34 and 35 degrees on average. but fluctuating. So again, we were really interested in this winter period. We wanted to see what was going on there. So remember, winter again is June, July, August period, and you'll see a lot of fluctuations around the mean. So very high maximums and very low minimum body temperatures. So pangolins were not regulating their body temperature very well during this time, which is very interesting. So we were curious again. So how are they responding behaviorally now to these changes in body temperature? And that was the next question. And I also just want to point out there are some really low lows on this body temperature chart, some going down to like 29 degrees, which is crazy if you think about it for a mammal. And those seem to correlate with rainfall events. And pangolins love rain, not super hard rain. They won't come out if it's raining too hard, but they love rain because ants respond to rain. And so even in the middle of the day, in the middle of summer, if it's raining, they will come out and they will enjoy the rain. But if even in the middle of summer, when it does rain, it can be quite cold. And so we think just purely having water on their body and being exposed to the environment. And again, they don't regulate body temperature very well. And so they had these declining body temperatures. So as much as they love the rain, it's probably not great for them. And then some exciting news that I discovered recently. So we had a pangolin that we had tagged back in 2015 and lost it early in 2016. So losing a pangolin is not unheard of. These tags fall off, they break, they die prematurely. Pangolins walk massive distances. There's so many reasons that you could lose a pangolin. So we lost him early in 2016. He had a body temperature data logger implanted into him. So it was very bleak when he disappeared. And I never found him for the next 5 years. And I assumed that he had died or moved out of the area. Who knows? But we found him totally by accident 5 years later. And yeah, eventually he took the logger out this year. And these star RD data loggers are only supposed to last maybe a year at that frequency of recording at 5-minute intervals. This data logger logged for almost 3 years. It's possibly a world record for the most continuous data set for any wild animal. Someone can argue with me. I wouldn't know better, to be honest, but I'm pretty sure that's a record. It's pretty freaking amazing, and I'm very excited. It does mean that I have to sit and analyze all of that data, which is going to be a lot, but the body temperature seems to be following the trends that we've been seeing. So being able to regulate body temperature quite well in summer and then massive fluctuations again in winter. So I'm very excited about that. And then if we zoom into some of this body temperature data and then look at that, I said earlier that we could estimate activity based on the body temperature patterns, which is super exciting for something like a mammal, because that's something you can do really well with reptiles, but not necessarily with mammals, purely because activity correlates with body temperature loss. So the more active you are, the more your body temperature will climb. And most animals are active a large part of the day or moving around consistently. And so there's lots of fluctuations in body temperature. But for a pangolin, as soon as they come out of their burrow, there's either a distinctive drop or a distinctive increase in body temperature. And so we could look at these 24-hour body temperature patterns, and we could say, this is exactly when the pangolin came out of its burrow, and this is exactly when it came back. So if you look at the top, for example, that's a typical summer body temperature pattern, where body temperature is fairly stable throughout the day, not fluctuating too much until it comes out at the first arrow. It comes out of the burrow, body temperature goes up, probably because of activity-induced hypothermia. So it's generating body temperature as it's walking, then it stabilizes a bit and then goes back into the burrow and it decreases again. Then if you look at winter, you've got a similar thing where, the difference is here, body temperature declines throughout the day, and then something happens and body temperature just plummets just before or just after it comes out. And any thermal physiologists in here that want to chat about why that might be, I'd be very curious to chat. I've got 2 theories, but we won't go into that now. But then the pangolins walking around. So in the winter, they come out earlier, and I'll show you that data now, earlier during the day. But because of that, their body temperature climbs when they're active during the day. And then they go back into the burrow once again, and body temperature declines. So it was a very neat way to try and estimate activity. And through that, I got those 4,000 records, which was very, very cool. Then this is looking at some of that activity data. I'm apologizing now because this looks blurry. It's not your eyes, I promise. I think that's just stretched out figure. So we've got emergence from the burrow on the y-axis, and then again months of the year on the x-axis. And we had predicted that during this nutritionally stressful time when food is scarce, that pangolins will come out during the day. A normally nocturnal mammal. It's been seen in so many other species where they do shift their activity. They come out during the day just so they can reduce those metabolic costs of keeping warm at night. They just can't afford to keep warm, so they have to come out during the day. And that's what we see here. So in the summer months, so anytime from October, November, December, January, February, you've got very late emergences. And we got, like, sometimes pangolins were only coming out at like 2 o'clock in the morning, which is remarkable for me because I have to become nocturnal with them. And then in the winter, which is again your June, July, August period, they were coming out during the day. And some of them coming out super early, particularly our pregnant females coming out at like 8:30 in the morning, which is crazy for a pangolin. But if we compare those 2 years, the first year was again the dry year. They were coming out significantly earlier. It doesn't look so obvious from this graph, but just believe me when I tell you, they did come out earlier during the day compared to the second year when there was a little bit more rainfall. So that starts piecing some puzzles together for us. This is the amount of time that they spent active when they did come out of their burrows. And we expected that when resources declined in the winter, we expected them to be active for longer to compensate for that. So you need to be out and feed for longer to be able to get enough energy. But they didn't do that. They reduced their activity time. And there's very sensible reasons to do that. If you don't have the energy to be feeding in the first place and to be active, you're going to shorten your foraging time to save energy. There's also another reason, and that's possibly by the time nightfall comes, again, it's too cold to be active. And so you have to just go back into a burrow to save energy once again. So it's all about energy savings. And so we were surprised that they shortened the activity period during this time, during winter. Don't be frightened by this figure over here. It's not, I'm not going to pay too much attention to all of it, but we're trying to figure out what drives pangolin emergence from the burrow. And if you speak to safari guides, you speak to people who have worked with pangolins before, they all assume that the temperature outside drives the time that the penguins going to come out. So if it's hot outside, they might come out later. If it's cold, they might come out earlier. And while that correlation might be true in some ways, it's not necessarily. So the top left graph, we looked at the time of emergence versus the temperature at the time that they came out. And there's absolutely no relationship with that at all. So temperature at the time that they come out was not related to the time that they actually came out. But then if you look at things like minimum daily globe temperature, so that's just averaging the monthly daily temperatures, there is a correlation, same with the maximum and whatever else. And there is a correlation, and I think that's just a seasonal effect. So in other words, it is hotter in summer, they are coming out at night. It's colder in winter, they're coming out during the day. But if we then look at, and we saw that with the photo period as well, which is your day length. So if your days were shorter, which is in winter, they come out earlier. If your days are longer in summer, they come out later. And then the top right one shows quite a nice relationship between prey abundance or insect availability and the time that they were coming out. So initially, if prey abundance is very low, they come out very early. Then it climbs up. So as prey starts increasing, they come out later and later, but then it plateaus. Then there's a time where it doesn't matter how much prey increases, pangolins don't come out any later. And it's probably because you cannot come out much later. If you're coming out at 2 o'clock in the morning, you're already shortening your foraging time because then sunrise is going to be approaching and you're going to be cooking in the sun. So it makes no sense to come out that late. And so they kind of plateau at that stage. The really interesting thing here was that if you look at the bottom right graph, which is looking at their minimum body temperature compared to what time they were coming out. When their minimum body temperature was low, they came out very early. When minimum body temperature was very high, they come out late. And that directly relates to the energy. So if you don't have energy, you cannot maintain constant body temperatures. You can't keep these high body temperatures. So your body temperature is low. And because of that, you have to come out during the day to compensate for that or to reduce the energy that you might use by staying out late. And so that was a really, really cool relationship that we saw. If we zoom in once again to the body temperature patterns and we compare summer and winter, I said already that summer was very stable. That's the green line. They regulate their body temperature really well during the summer. During the winter, it just falls apart. So this is again when food is scarce, they don't have energy to maintain those body temperatures. So you can see body temperature declining throughout the day. And then that dip happens, and then they're walking around during the day in daylight, exposed to solar radiation, and you get this spike in body temperature. And it's quite alarming. It's quite an intense spike sometimes up to 8 degrees, which is crazy in a short space of time for an animal like that. And then they forage around, and around sunset, body temperature starts lowering again, and then they go into a burrow and body temperature goes down. And then again, throughout the day, it declines. So it seems that resource availability is a very, very important thing for being able to regulate your body temperature. And if we compare the same animal on the same day, but during the dry year and the wet year, we see quite distinct differences, particularly during that first day that I'm showing. So the red one was the dry year, where you see much more fluctuation in body temperature compared to the wet year, where there was still fluctuation, because it was still, I mean, as much as we had rain, it wasn't amazing rain. It was okay rain. And so there was still going to be fluctuation in that body temperature. But that's just unreal. And your body temperature functions at certain temperatures for a reason, because enzymes are active at certain temperatures. They need to be working at optimal temperatures. And so we don't yet know what these massive fluctuations do to these animals, but it's probably not good. And I didn't have any pangolins die during the time with these loggers in. And so we don't quite know what their thermal limits are. But years after that, we did have a couple of animals die, didn't have data loggers in, but they were very skinny. They were not doing well. So I imagine that they would have these crazy fluctuations like in this dry year. So not only are these poor guys threatened by the illegal wildlife trade, by fences, by habitat loss, potentially now by the impact of climate change as well. Again, directly on their body temperatures, you saw how their body temperatures were spiking during the day when they came out early. If daytime temperatures are getting warmer and warmer, that's just going to be worse and worse, that climb. And they're going to really be approaching their lethal limits. And then indirectly, of course, through their insect resources. So if they don't have any insects, they really don't have the energy to regulate this body temperature. So it's not looking good for these guys in terms of climate change. This is just a really cool video. I didn't want to end it on a sad note like that. I just wanted to show you this really cool video. This is just a pangolin under a thermal camera. I'm just showing that those scales, as much as you might not believe it, they kind of do offer at least some insulation, not much. Those red patches that you see on the body is the naked skin. That's the really hot parts. Including, I think the hottest part is the ear, just behind the eye, and then the inner legs that are not covered in scales. But those parts that are covered in scales are fairly well insulated. You know, the background, the black background is the coldest part of the image. And so the body, if the body was super cold, it would be black. If it was releasing no heat through the body, it would be totally black. But it's not totally red, so it's not completely releasing all of the heat through the body and through the scales. Otherwise, it would be lit up red like a Christmas tree. But it is about more than just pangolins and aardvarks. As much as I do love pangolins and I do love aardvarks and I love working with these animals, we need to remember that ecosystems exist and the effects on one organism are going to play throughout an ecosystem on another. And that's where the Kalahari Endangered Ecosystem Project came into effect. So that's really looking at ecosystem responses to climate change. So looking at how if climate change impacts one organism, what are those cascading effects throughout that ecosystem? What are those links? How does one player play on another throughout climate change? And that will help us to identify the most vulnerable players, and then we can start putting in appropriate management strategies to see who we should be conserving first and who gets priority. So I've just got a small example of how our little food web came along. We had to sit down and make a very basic food web. We can't study everything. I'd love to, but we can't. So we had to narrow it down. So we're studying the grasses first and foremost. It's the base of our ecosystem. Yes, insects are probably the more base of every ecosystem, but we'll get there. Insects depend on grass, so they need the grass. Our herbivores need grasses and other vegetation, trees and stuff. I've got a black circle around them because we aren't quite studying antelope and herbivores yet, but we will get there. And then you've got all of these things that feed on insects. And so if you've got impacts on your grass, you're going to have impacts on your insects, and then they're going to play through the ecosystem on all of your pangolins, your aardvarks, your birds that rely on insects and grasses, things like lizards that depend on insects, things like little bat-head foxes that depend on insects. The cool thing about foxes, or bat-head foxes at least, is that they are more generalist species, so they're not so specific on ants and termites particularly. They can also go for things like dung beetles, sometimes even fruit on some trees, so slightly different to our aardvarks and pangolins. And then you've got some raptors, for example, that will feed on bird chicks or lizards, so they become important in our ecosystem and they'll be impacted. And then their predators, the snakes, for example, that will go and feed on birds. So there's a huge ecosystem at play here. And so it's really not just about one thing. And so we've come together as a group using existing research at SWALU as well and said, We're all after the same goal. Let's link together, share resources, and understand this ecosystem, and then understand their responses to climate change. And so what will happen if we lose our grass because of increased temperature and decreased rainfall, for example? There's no groundwater for grass to go. We have massive impacts throughout our ecosystem, and we could lose whole ecosystems for something as silly as that. Fortunately, if we do have balanced ecosystems, healthy ecosystems, it's more resilient to climate change, then there's a fighting chance, but we need to control that. We need to reduce CO2 levels. We need to manage our land. We need to make that better. I just needed to mention that we are proudly driven by Suzuki Auto SA. They didn't ask me to do that, but they've been a huge help in getting us around the study site with 3 amazing vehicles. So we are very, very grateful for them. And I will stop talking there. If anybody does want to get in contact with me, there's my email address and the Keep Project email address. Please feel free to engage. I would love to hear from everyone. Okay, cool. I'm done now.
We've got the first question lined up from Lorraine. I'm going to unmute you, Lorraine, and then I've got a couple of other questions that came through on the chat. Go for it, Lorraine.
I love it. I've never been honored to see a pangolin, so I'm quite jealous. I'm curious. I mean, you started the talk about climate change. And you ended it that way. I'm wondering, and I also noticed that you're being sponsored by vehicles. Have you had ideas on how to bring this whole ecosystem out to the wider world so that you can work together on climate change and show the effects or the possible effects this is going to have?
Yeah, we are trying to collaborate with bigger climate change experts at the moment to get a real grip on this, because we're all ecologists and animal behavioralists. We don't particularly understand climate change very well, so we are trying to get our hands on people who have more influence in that department. And I feel your comment about us driving around in vehicles. I get you completely, but it is a huge reserve we have to get from A to B. We are very grateful that the support we get from Suzuki, they are trying their best to be as environmentally friendly as possible. And the vehicles they have given us is low fuel economy, low impact on the environment compared to a big, not going to say a brand, but like a big truck, for example. So they've given us things that have as low as possible an impact on the environment. But yeah, we are working on that. We are trying to get a bigger impact, a more global impact. The project is very new still, so we are working on it. We need funding first and foremost. But yeah, we're getting there. Yeah.
Yeah, I didn't want to sound it like I was attacking you. It's more of a personal thing, because I'm working on a film that I'm hoping is going to bring motorbikes to rangers, and I realized the contradictions. I'm like, okay, how do I reconcile this issue? And I mean, every national park in Africa is the same. It's huge. You need something to get from A to B. So exactly. I was wondering if you had solved any of these problems for me.
If I do, I'll get back to you.
Okay, thanks.
Thanks very much, Lorraine. Andrew, I'm going to ask you to unmute.
Thanks very much, Wendy. Very much entertaining and informative talk. Now, as anyone else can understand, there is so much trafficking on this species. Are you maybe succeeding in trying to curb the amount of trafficking that is happening on this species?
Yeah, so that's not my expertise. There are several people that are, and some of them are in this chat right now, that are doing their best to try and curb that kind of thing. My hands are full with ecological side of things. I would love to be able to solve all of Pangolin's issues. Unfortunately, I just don't have the time or expertise to do all of it. But But what we are learning in the wild is we are certainly, hopefully, contributing to, so there's a huge pangolin rehab release program. So if pangolins get confiscated from the trade, they go into a rehabilitation and then release program. But we don't know enough about wild pangolins in the first place to be able to know how pangolins will respond to these things. Okay, there is a lot of good work going on now monitoring pangolins post-release to see how they are responding. But as much as we can learn on the ground now about wild animals and wild pangolins, then we can hopefully contribute to our greater understanding of these animals. And so it might not be mitigating or stopping the trade in the first place, but it certainly is helping the process after that. If we did need to release them back into the wild, we are gaining a better understanding of how they do cope in these environments.
Okay, thanks, Wendy.
Thanks, Andrew.
Okay, cool. Thanks, Andrew. I'm putting you back on mute. Holly has a question for you, Wendy. Holly, I'm asking you to unmute. No, unmute. There you go.
Hi, Wendy. So this question is coming from, I've seen 2 pangolins in my life, both of them in Uganda. One a tree pangolin, which was alive, and the second one was a ground pangolin, which was dead, but it was dead with its head down a termite mound. So, wow. Which is very, very strange, and it wasn't stuck in any way whatsoever, and there were no predator marks. So I don't know if you know Ian Sinclair's research in the Serengeti in the 70s, and oh my goodness, okay, so you know, it's to do with how do animals die. They're either going to be predated or they're going to die of starvation. Okay, yeah. Die of starvation, i.e. they don't have the energy to escape a predator, or a predator will eat it after it's dead. But one of the ways to tell if an animal died of starvation is a bone marrow check. And the bone marrow will tell you exactly if that animal died of starvation or if it was a predator who took it out at its health. Obviously, to do bone marrow, you've got to kill the animal or find a starved animal, which is very tricky. So my question in your food web was, you had nothing predating on aardvarks and pangolins, but there must be predators. So thinking back to this dead ground pangolin that we saw in Uganda, how did that die? Do you think it's possible that it's a snake? And how often have you seen snake pangolin run-ins? Or because they're known to share burrows, right? So absolutely. Yeah, I mean, I don't know how clear that question is, but there we go.
No, I got you. I've seen pangolins and snakes kind of interact, not physically. Pangolin comes across a snake. As soon as it hisses or makes a noise, pangolin goes in the opposite direction. That's just a handful of observations I've got. Hang on, you had another question. Oh, the lack of predators in my food web. So it's not to say that these animals don't have predators. They certainly do have natural predators. There's a lot of lions and leopards that kill aardvarks all the time. That's a normal thing. And
for sure.
They try and kill pangolins as well. That scale covering is pretty effective. Not all the time, but pretty effective. We've excluded predators in our little food web. We're not saying they don't exist. They're just not in our study right now, because predators are probably the last to suffer from energy deficits. So they've got a range of things to feed from that are going to die because there's no grass or whatever, but the predators are last in line. And predator studies are so on the ball. There's so many predator studies. There's very few studies on the rest of the little food chain. So for now, we've excluded the predator side of things. Our lab does have some work on wild dogs. They're not feeding on pangolins and aardvarks, but similar kind of work. They're not necessarily part of that project now, but they do fulfill that little predator niche within the work that we're trying to do. As for your pangolin in a termite mound, when you found it, was the body still there, or was it eaten away already?
No, it was in perfect condition. We thought it was alive. We crept up on it, and it was upside down with its head in the top of the termite mound, like a higher mound, and we thought it was alive, and we waited, and then we crept closer and closer, and finally we got there, and it had rigor mortis, no injuries. It wasn't stuck. It came out very easily, but it was upside down and dead. It was very strange.
At all?
No, well, it's difficult, no, I would say it was in good condition.
Well, it could be something totally bizarre. I mean, pangolins are so prone to infections, and these guys that do animal rehab and rescue, they'll tell you they are very prone to infection. So Yeah, that's quite mind-blowing. I have no idea.
It is. And just to kind of end that, because, you know, and definitely have a look at Ian Sinclair and his bone marrow work in Serengeti, because also your temperature fluctuations are also a way to control parasites and other amoebas, instead of it being, you know, you wonder how they're surviving. It's actually a control mechanism because they're more affected by.
Yeah, no, that's good. Thanks, Holly.
No worries.
Yeah, I would just like to interject and say something here that you know, there's this belief amongst people that pangolins don't have any predators because they can roll up into a ball, and that is not true. They certainly do have lots of predators. Yeah, and snakes. You know, our small pangolins are easily taken by crowned eagles and leopards and things. Lots of things can eat pangolins, and they're not invincible. So yeah.
Just to comment on Holly's conversation now with Wendy as well, Lexus has made a comment in the chat area now saying possibility of it being stung by a wasp or a scorpion ? So that's I don't know if I can't see Alexis on my screen at this point in time, but I don't know if Alexis would like to come in and ask her questions, because she had another question for you, Wendy, as well. And
no, it's not impossible, Lexi. I mean, it could be these freak events where something just runs in. I'm sure Jonathan would love his scorpions to stand a chance against a pangolin. I've seen pangolins stomping all over scorpions like they don't even care. It's pretty remarkable.
I see Jonathan answered there that he's done a scorpion survey of Tswalu, and it's unlikely that a scorpion would cause the death of a pangolin. But I think from what I remember, we've had a pangolin death caused by a wasp. So, you know, a pangolin ingests a wasp by mistake, as part of its kind of general, you know, foraging, and definitely died as a result. There was just another thing I wanted to ask you, Wendy, which was, how do you chart the energy of ant species?
Yeah, so we collect those pangolin specific ants, so whether it's the cocktail ants or the pugnacious ants, and then we bomb them in a bomb calorimeter. And that does a whole bunch of fancy things and just returns an energy value. Yeah.
Wow, fabulous. Thanks.
Okay, and then just to come in as well, Leno Sierra would like to come in on this conversation. So I'm just going to ask him to unmute.
Thank you. Thank you so much. Thank you, Wendy. All of this was amazing. Hi to everyone. I just want to give a little input on my experience in the field with pangolins, talking about this subject, about the scorpions and the wasps and these other creatures that can stung them. On my experience, I've seen a lot of interaction of pangolins during the rehabilitation, long periods of rehabilitation of months that I've been able to do. And I've noticed, I don't have scientific proofs yet, but that they have some kind of immunity to most of these creatures. They definitely get stung by centipede, by scorpions, by spiders, by everything that is inside the burrows. And they show some strange reaction. I would describe it similar to maybe mongoose and some other animals that have immunity, a little bit of a shocking for seconds, kind of a tiny little seizures that of course stops my heart, maybe not theirs. And I'm just thinking like, what is going on in this? And then a few seconds after, the pangolin is perfectly fine. So I have no clue, of course, what happened in that event that, I'm sorry, I don't remember the name. The lady was talking about this dead pangolin with the head inside the burrow. But I think, of course, there is a probability, but I also think they have some kind of defense against these things, because I've opened so many termite mounds and I've seen what's inside every time. And I'm sure they have some kind of protection or immunity to these things. Not perfect, and I'm sure they can die as well, as Alexis said, by ingesting a wasp or some things like that, or maybe their immune system is not in a good condition and all of our pangolins have been rescued and their immune system is compromised. But I really think they have some kind of immunity, maybe not to very, very venomous snakes, but just to those creatures. I just want to share that information.
Thanks, Leno. I think what we're getting from this is that we still know so little about these animal interactions in the wild. It's unbelievable.
And thank you so much. Thank you so much for finally proving in paper and data that they're led by temperature, not by light. I just love it. Thank you so much.
Thanks, Leno.
He said they're led by temperature, not by light. So.
Martin Brath had a question as well, where he said it's a fascinating insight into one of the world's most elusive creatures. And he wanted to ask a question here. I've lost it now. So I'll come back to him. Beta Limwe asked two questions. Which are the pangolins, or where do pangolins normally stay, and what area do pangolins normally stay in during the hot season?
The pangolins will use any little nook or cranny they can find, really. So mostly they're staying in burrows out in our environment, but also in the hills. I think our mountain range is severely underestimated in terms of the capacity for being habitat for pangolins. I know it's the same in the Lowveld where there are some hilly terrain. They'll find rock crevices, they'll find caves, they'll sleep under grass, under bushes, inside termite mounds. They'll sleep anywhere. Summer, winter, doesn't matter what season, they find a nice little place to stay.
Perfect. Are there any other questions in the room that Holly? I'm asking you to unmute.
Just an interesting one, and I don't know about your area if there's water, but can pangolins swim well, and do they go into water by choice or not?
I think there's other people in here that could probably answer that better. I've never seen them swim. I've heard they are pretty good swimmers, and I've heard that they love water, mud mostly. I've never seen a pangolin come across water. We do have freestanding water here, but I've never seen a pangolin seeking water or going to the water. I've seen them drink water once, just at the base of a tree that had held water from the rain the night before. But other than that, I've never seen any interaction with water. But I'm sure someone else here might have seen that at some stage.
Yes. In Central Africa, we have never seen them swim. We've heard stories of them swimming, but we've never seen them go into water deliberately. I've never even seen them go into water accidentally. We've had people tell us they found them in the water, but no, there's no evidence here. In Southeast Asia, I believe it's different, but here it's definitely, they definitely don't go into water voluntarily.
So interestingly, in Uganda, the ones that I saw were on islands. So to get there, they would have had to swim. And we went through a pretty actually horrific where the Chinese built a hydroelectric. We tried very hard to get permission to get all the animals off this archipelago of islands. We didn't really succeed, and so we had to send out kayakers as the water was coming up, and two of the pangolins, climbing higher and higher up the trees, but as was everything from insects to snakes to monkeys, were having to swim off as the water came up. We did manage to catch the pangolin, and the one. There were others on other days, but yeah, they swam pretty well there, but those were tree pangolin.
I'm saying they can swim. I mean, they fall in the water, they can swim. They're very buoyant, but they don't want to swim. Most things can swim. I promise you, anything that falls in the water can swim, but they don't want to swim. It's not a voluntary thing. But presumably to get to an island, they've crossed there sometime, maybe in a dry period, or they have swum across there. But they certainly can swim, but they don't do it of their own volition.
Thank you.
Thanks, Holly. Thanks, Rod. Alexis would like to come in again. I don't know. I'm asking you to unmute, Alexis. I don't know if it's related to the same question of swimming, but ask a question, please.
No, I just wanted to go back to the question of the pangolin that died in the termite mound. to say that I checked with Nikki Wright quickly, and we definitely had a pangolin that died of anaphylaxis from a wasp sting. That was confirmed in a post-mortem.
Amazing.
Wow, that's amazing.
Very interesting.
Thanks.
Yeah.
Yeah. You know, here
Jonathan?
we have some of our pangolins actually eat honey. They raid beehives, but they're stingless bees. But I'm sure they would probably raid stinging bees as well. We just haven't seen that happen yet. But they certainly a part of their diet is stingless bees. Like Wendy, very little of their diet is of our long-tailed pangolins is of termites, but certainly a higher percentage of them is bees and honey.
Amazing.
Thanks, Rod. Jonathan, you had your hand up. I'm going to ask you to unmute.
Yeah, when it comes to anaphylaxis, there's no link between wasp venom and scorpion venom, and this is in humans. Don't know about pangolins, Wendy, but pangolins are mammals, right? So there's probably a good correlation there. So there's something about wasp venom, and there's something about bee venom as well, which will cause anaphylaxis, or it's very common. I wouldn't say it's very common, but it's more common than scorpion venomation, and also spider bites as well. We've never had anaphylaxis for spider bites.
With the pangolin that Alexis was talking about, that's a pangolin that ingested a wasp. So I think with the scale covering, the chances done by something is pretty slim. They're not completely covered in scales, but at least the outer bits that are exposed to the environment most of the time are going to be pretty invincible to things like scorpion stings. So I think if it's going to happen, it's going to be a very rare encounter.
Martin Brask had his question, which was, what area does a pangolin typically cover in a 24-hour foraging cycle? And I would imagine that will change over between your winter season and your summer season.
Yeah, so we haven't yet compared the movement data between summer and winter yet, but we've never quantified the distance that they're moving every single night. But it's so variable between individuals. Like, this is just anecdotal. Like, you can have a pangolin that's not going to move more than 100 meters overnight. You can have a pangolin that's going to move 10 kilometers overnight. So it can be extremely variable. But typically, if I'm just thinking like on average, we'll have a pangolin maybe moving not more than 2 kilometers out, and then it comes back to that burrow. But if it's planning to move to a new burrow, sheesh, it's going to go until it finds that burrow. They can mission quite large distances, but not more than a couple of kilometers every night.
Cool. Thanks, Wendy. Another question.
Do you have home range data, Wendy?
I do. I haven't analyzed it yet.
Sorry, Wendy, do you have home range data?
Yes, Rod. Haven't analyzed it yet. It's sitting there.
I'd have to ask Tam, but we have some.
That'll be a cool comparison with your little tree babies.
Rod. Yeah, but ours are walking at 50 meters above the ground. Yours are walking on the ground.
Chris,
would Tam like to come in and maybe add something in this, because Tam works on it all the
Tam has just gone off. She just had to go and do something, so she's not here.
Yeah, as long as she didn't go to, Rod, as long as she didn't go to fetch you a beer, and then she's excused. But when she comes back in, ask her to join us.
How well do you know Tam? She's never gone to fetch me a beer in her life.
Good for you, Tam.
Okay, so I've got a question here. Well, not really a question, but more a comment from Fran Gebhardt, where she asks the question, surely this is the most in-depth study of pangolins. Wendy, I'm assuming that you would have done peer reviews and stuff like that, so I would assume that you would know.
Yeah, well, in terms of ecology on this species, there's been 2 pretty extensive studies before. This kind of takes it to another level with the body temperature stuff and the energetics. But yeah, I guess it depends on the discipline that you're into. Like, there's some really good stuff with the rehabs, like really extensive stuff with the rehab and release programs going on now. So when it comes to ecology in wild pangolins, yeah, not much going on there. So I like to think that I've made a little dent in that knowledge gap.
Thanks, Wendy. Liesel, see your hand. I'm going to ask you to unmute.
Hi, Wendy.
Hi,
Although
Liesel.
I am in a zoology department, I don't know nothing about pangolins. While we're talking about the diet of the pangolins and the soil content, is this not an example of geophagy, like we find an antelope and even an elephant? Is it not worthwhile while doing the scat analysis to see what is the mineral content in that there for what they can subtract from the soil as well?
Yeah, totally. That's yet another thing that we can still do with pangolins. I just don't think they're doing it intentionally. I don't think they are specifically taking in soil for the mineral content. If you watch them feed, they're not interested in taking in soil. They're interested in taking in the ants. The soil is just a byproduct, but it certainly does help the digestion process. So yeah, but geez, that'll be an interesting thing to do. Let's do it.
Thanks very much, Liesel. I've got a question here from Katerina Hecker. Do ground pangolins dig their own burrows?
They can. They're not very good at it. They can though, but they usually use burrows from other animals like aardvarks, porcupines, whatever they can find. On the odd occasion that I have seen them dig their own burrows, it's a very sad looking burrow and their body is sticking half out of it. So they should stick to their day job of stealing other homes instead of making their own, in my opinion.
Thanks very much, Wendy. I'm just smiling about that the story that Holly told us just now about the pangolin that was stuck or not stuck in the hole.
Yeah.
It could well have been trying to build its own burrow. Brilliant. Polani asked the following. He says, if I may ask, did any of your tagged pangolins get electrocuted at some point during your research? And if so, was there a spike in their body temperature for a brief moment after that incident? I know my question might be a bit far-fetched, but I would imagine it's got something to do with ground pangolins having run-ins with the tripwire on game fences.
Absolutely, and not far-fetched at all. That happens a lot. They do come across fences a lot. I did have one individual that did come across a fence with the body temperature implant. There was nothing at all on the body temperature stuff immediately. There might have been something later, but I wasn't with the animal at that time to confirm that something happened with the body temperature. But it also didn't get electrocuted like really strongly. It was just passing under the strand and its back was getting electrocuted. It also happened to have a little baby on the back and the baby got electrocuted, but we didn't have the baby implanted at the time. So the baby was responding more strongly to that electrocution, but nothing obvious in the body temperature. But we definitely looked at that because it's something interesting, certainly.
Thanks, Wendy. Another question from Fran Gebhardt here. Do they mate for life and or are they monogamous?
Ooh, that's an answer I can't give. Maybe somebody else in the pangolin world can. I've only ever seen one situation, which is actually this year now, because I very rarely had individuals overlapping in home ranges. So I never saw them come together until this year. But we have a very big male patrolling 3 female home ranges, and he's definitely spent a night or 2 in at least 2 of those females' burrows. I am not going to talk on this platform about what might have happened down there, because that's just PG-18 stuff. But yeah, I speculate 2 of those females are pregnant now, so let's leave it at that.
Right, Lino, anybody want to come in and have a comment on that?
Lena doesn't want to come in because she's just switched her camera off. Rod, would you like to comment?
Yeah,
I can come in, but I'm in the same spot. I mean, I'm hoping that someone here can tell us. We've also had some kind of sure interactions between pangolins. We don't think they are monogamous at all. They just meet to mate. So it seems like the males are not involved at all on the offsprings, raising them or anything, but we know very little about them, about it.
Yeah.
Yeah, they're like solitary cats, is what we understand. I mean, the male will come in and cover one female and it'll move on and cover another female. That's what we believe is happening, but there's so little data.
It's crazy. As an animal that occurs at such low population densities and are solitary most of the time, to be monogamous seems like a crazy thing. Like the chances that they have of coming together, you got to take that opportunity, whether it's your monogamous partner or not. You got to mate and get your genes going to the next generation. So yeah, who knows?
Cool. So this would then go into Cheryl Ogilvy's question, where she says mating and offspring ? Data. So I'm assuming there's not much data that's out there regarding the subject.
Yeah, I mean, I've never seen the mating myself. It sounds super weird, but I'm dying to see that happen. I'd love to see a pangolin mating. Just want to know what's happening and how it's happening. But in terms of offspring, I've seen a lot of babies over the years, which is quite nice. Out here, they seem to be very seasonal in terms of giving birth. So it's almost religiously in the middle of September every single year, never outside of that period. And I know on the eastern side of the country, there's quite a bit of variation in that. They give birth to one baby at a time. They carry the baby on the back, which is super exciting. And they only bring the baby out when they're moving to a new burrow, so they don't forage together. Again, I'm just speaking with this particular area, what I've seen in the pangolins here, so I can't really speak for other populations elsewhere. But yeah, no real hardcore data on that side of things. It's very tricky because they do most of their business in the burrow. They hide it away. They're very private little animals.
Thanks very much, Wendy. I see there's a comment here as well in the chat from Alexis again, where she goes more from Nikki, right? There is apparently a wasp that cohabits with termites. And that I find is quite an interesting ecological mutually beneficial relationship there on that subject. Are there any other questions in the room for Wendy at this point in time?
I think we've got an answer question. He just made a comment. He said, "Thanks, Wendy. Very interesting. Shows how much we still have to learn about the species, despite all you've found out. You know, so there's still so much to learn.
So much.
Yeah,
we've got a long way to go. But it's cool. It's cool to work with an animal like this, where there is still so much to learn. Not easy, of course.
So Cheryl's got a whole lot of students, and I think Liesl might have some students in the room this evening. But there's certainly definitely scope to look into the reproductive behavior of pangolins. I don't believe that pangolins exist. I've never seen one. I think it's a mythical creature. I don't know what you are smoking, Wendy or Rod or Alexis or any of the other pangolin people here.
It's one big joke that we've been running on the world.
And none of you will invite me to come and see these pangolins. So,
question, yeah, Chris, from I think it's Sybil. How invasive was the planting logger, and was it removed later again? So yeah, we did everything in our power to make it as minimally invasive as possible. Obviously, putting anything in an animal or touching an animal is invasive in the first place, but we went lengths to try and reduce any impact. So there was never a reaction to the data loggers. They healed incredibly well, and they went feeding straight after we did implants. And so, but we monitored them very closely to make sure that they are doing okay. Had a vet on standby if anything had to happen, and we did take the data loggers out afterwards. So unfortunately, with these data loggers, you have to take them out to download the data. So if you lose your animal, you lose your data, which is really, really sad. But yeah, so we did take them out of the animals.